Welcome to the Year 10 PPE Paper 2. This is the calculator paper. This means that you can use a calculator for any of the questions, but for many you won't need to, and even if you do use it, you must show clearly all of your working out. Okay, first question. Prime factorization of 84. Start by writing 84. At the top of a factor tree, bring down two branches, splitting it into a pair of factors. Usually we start with 2 if it's an even number. Okay, if it's a prime number, which 2 of course is, circle it, but continue the tree on the other part in the same way. 2 and 21. Okay. If it's prime, circle it. If not, carry on. 21 is 7 and 3. Both prime numbers. And that's the end of the factorization. What we do now is write them in a list with multiplication signs. We can either say 2 times 2 times 3 times 7, or we can have 2 squared times 3 times 7. Okay. Part B. To find the lowest common multiple of two numbers, if you do the factor tree for each one, you can use a Venn diagram, which I've sketched here to finish the job off. So I'm starting with the 60, okay, and I'm going to do the same as I did earlier. That's 2 and 30. The 2 is prime. The 30 splits to 2 and 15, okay, and the 2 is prime. The 15 will split to 3 and 5 in this case. Okay, so all of those numbers in circles are prime numbers. Now, to find the lowest common multiple, I take them off in pairs first of all and fill out the middle part of this. So this Venn diagram, let's say the one on the left represents the 84 and the one on the right is the 60. Okay, so I'm going to put in the middle the factors that belong to both 84 and 60. Well, if I go over here, I can take off a 2 and a 2, okay, because they belong to both 84 and 60, and I can put a 2 in there, okay. Then I notice there's actually another 2 that pairs off with that one there and that one there, so that means I can put that 2 in as well. No more 2s, but there is actually another pair I can take, which is a pair of 3s. Okay, so let's put that in here, because those 3 belong to both lists. Now we come to a 7, which doesn't pair with anything here. So that 7 only belongs to the 84. So I can put that in there. Okay, and then I'm left with just a 5, which goes in here because it only belongs to the 60. And now I've used up all of the numbers. Okay, now this is how it works. It's very simple. If you're asked to find the highest common factor, the HCF, you simply multiply the numbers together in the middle, okay, which is 2 times 2 times 3, okay. And sometimes they ask you for that. If you're asked for the lowest common multiple, you do exactly that, but you also multiply it by whatever's left over outside, which is the 5 and the 7 in this case. That's the lowest common multiple. Work all that out, you get 420. Okay, and that's the answer. It means that the smallest number that divides by 84 and by 60 without a remainder is 420. Next question. This is another Venn diagram question as it happens. Okay, the universal set is the numbers 1 to 10, the counting numbers. A are even numbers only, and B are factors of 10. Okay, some of those belong to both groups. So the factors of 10 that add up to that are also even numbers are 2 and 10. All right, so 2 is an even number and a factor of 10, and so is 10. Okay, the rest of the even numbers that aren't factors of 10 are 4, 6, and 8. Okay, from that list. And the other factors of 10 are 1 and 5, which are both odd numbers, so they don't belong in set A. But we've got some left over. We've got a 3, a 7, and a 9, and they go outside of the circles. Now, a number's chosen at random from the universal set. That means from any of the 10 numbers. Find the probability that this number is in the set A intersect B. Well, intersection is the bit in the middle. Well, there's 2 numbers in there out of a total of 10. So it's 2/10. Okay, you can write it as 1/5 if you want, or 20%, or 0.2, but we tend to just keep it simple. And in probability, they don't require you to simplify fractions, so just leave it like that. Okay, next. Right, now this is an interesting little ratio problem. Okay, you just need to make sure you've read and understood the information, because there's 5 marks here, so there's a bit of time needed on this and working out to be shown. So the tins are put into boxes. Every small box contains 6 tins. Every large box contains 20 tins. And 3,000 tins in total are put into the boxes, so that the number of tins in small boxes to the number of tins in large is 2 to 3. Okay. Now, the process I would follow here is a classic ratio situation. Add the 2 parts together to get 5. Okay. And then divide the 3,000 tins by 5. Okay, to get 600. Okay, so if you've got your ratio adding up to 5 parts, it means 1 part is worth 600. So 2 parts would be 1,200. 3 parts would be 1,800, and so on. So then I can say that the ratio 2 to 3, okay, in this case is 1,200, okay, to 1,800. Okay, and those 2 numbers of course add up to 3,000. So basically I've got 1,200 tins in small boxes. If I just put up here S and L here, okay, I think these sorts of abbreviations are clear enough, because it just says show all your working. It's not asking you to explain the working, it's just asking you to show it. Okay, it's very evident from that you know what you're doing. Now, if I say that there are 1,200 small boxes, there's 1,200 tins in small boxes, 1,200 tins in small boxes, and each small box contains 6 tins, then the number of small boxes is going to be, okay, it's going to be the number of tins in small boxes divided by 6, because you get 6 tins in each one, which is 200. So I've got 200 small boxes, okay, and large boxes, okay, same sort of calculation, but this time I'm going to have 1,800, okay, 1,800, and each one of those large boxes contains 20 tins, and that gives me 90. Okay, so I've got 90 large boxes and 200 small boxes. Carlo says that less than 30% of the boxes are large boxes. Okay, now what I'm going to do is I'm going to say that the total boxes is 290. Okay, total boxes is 90 plus 200, okay, which is 290. And now we want the percentage, which are large. Okay, so percentage of large boxes. Percentage of large boxes. And the percentage is going to be the number of large boxes out of the total number of boxes times 100. Okay, and if you put that on the calculator, that comes to 31.3%. Okay, and now we need our conclusion, and this is so important. I'll just write it up here and highlight it. So Carlo is wrong because, let's do it here, yeah, Carlo is wrong. Okay, and then a reason. Carlo is wrong since 31% is greater than 30%. In other words, we're doing some kind of comparison with the information that was given to us. So that would be my conclusion. Not just Carlo is wrong, full stop. That isn't sufficient. You've got to have reasoning and evidence with your conclusion like that. Okay. Next question. This is quite a simple trigonometry question. Work out the value of x, the length. So you're working out a length. You know the hypotenuse. You've got the opposite to the angle. So the opposite over the hypotenuse is the sine of 34. So you must write this down. You must write down sine 34 equals x over 178. Okay, don't just go straight to the calculator. So if that's true, multiply both sides by 178. You get that 178 multiplied by the sine of 34, okay, equals x. Okay, and then you just put that in the calculator, and that comes to be 99.5. okay, 99.5 to 3 significant figures, or one decimal place. It says 99.5, and it is millimeters. Okay, millimeters. Okay, they haven't put the units here for you, so you must make sure you do, to 1 dp. Okay, make sure your calculator is set to degrees. Okay, if it's a Casio and you need to reset it, you go through the sequence Shift 9 1 equals AC. That will reset the calculator to degrees and factory defaults. Next. Okay, we have a right-angled triangle stuck to a quarter circle, a sector, okay, with an angle of 90 degrees. And we've got to find the length, well, we've got to find the area of the quarter circle, all right? But in order to do that, we need its radius. And its radius, I just call this R, is the same as the short side of this right-angled triangle. So I need to use Pythagoras to find R. So R squared is 9 squared minus 6 squared. So R is equal to the square root of 9 squared minus 6 squared. Now don't forget we're subtracting because it's the hypotenuse that we know and one of the short sides. And we've got to find the other short side, you see. Well, if you work that out, you've got the square root of 81 minus 36, which is the square root of 45, okay? Now don't work out what it actually is, because we don't need to know as a decimal, because then we're rounding, we're introducing errors. Just leave it as root 45, because then we're going to use the fact that the area of a quarter circle is a quarter of pi r squared, yeah, because the area of a circle is pi r squared, okay, which is a quarter of pi times, well, you see, what you're doing is you're squaring root 45. So to show all our working, I'm going to put the root 45 and I'm going to square it. But hopefully you can see that if you square the square root of 45, that is the same as 45. Okay, so we're left with 45 pi over 4. Okay, and this is important, you see, because if your calculator failed or you didn't have it with you for some reason, this would give you not all of the marks, but it would give you 3 out of 4 of the marks, because you've done everything up to this last point, you see. Okay, and you've shown that you understand the problem. The final stage, of course, is to put that in the calculator and evaluate it. It comes to 35.34. Okay, 35.34. That's what you get off the calculator first, 35.34. And I normally just go to a little bit more accuracy and a few dots, and then write that to 3 significant figures as 35.3, okay, meters squared to 3 significant figures. Well, we've shown that we've rounded to 3 significant figures by writing that down and then converting it to that. Okay, so we've answered that question. Next. Tariq buys a laptop. He gets a discount of 5% off the normal price. So this is a reverse percentage problem. If you found 5% of 551 and added it on, you would get 0 marks, because that's completely not what you do. What we do know is that 5% was taken off, leaving us with £551. So that means that the 551 was 95% of the original price. Okay, 95% of x equals 551. Now you should define what x is, of course, so I'm just going to call the normal price x. Okay, now if that's true, then 95% is 0.95. 0.95 times x equals 551, and therefore x is just a simple equation, 551 divided by 0.95. Okay, now you should know if you're dividing by a number less than 1, a fraction if you like, between 0 and 1, the answer you get is bigger than what you started with, and it is indeed £580. Okay, and it's easy to check. Just take 5% of 580 away, which is 29, and you'll get to 551. But you shouldn't do it by trial and improvement. You should use this method, get the answer, and then check afterwards that it works. Right, okay, now we have investment, £6,000. Okay, at the end of the first year, it's increased by 2.4%. So that means you have 102.4% of it, okay, which is 1.024 multiplied by what you started with. And then for the next 2 years, you add 1.7% each year. So to increase something by 1.7%, you multiply it by 1.017. But because we're going to then do that after the next year as well, we can just square that. Okay, and that calculation will give us the amount at the end of 3 years. Round it to the nearest penny if you need to, and in this case we get 6,354.67. Okay, always check that the answer seems reasonable. Obviously you'd expect the answer to be more than 6,000. If it wasn't, you've obviously done something wrong. Okay, so that's quite an easy 5 marks there. Just be careful and show your calculation before you go into the calculator and work it out. Do not be tempted to pick the calculator up, type that stuff in, and just write the answer down. It's a huge risk and you'll lose loads of marks. Next. Now, this can be a bit difficult to read sometimes, these little graphs, so just be very careful and look for what they are looking for, if you see what I mean. So we've got some information from a table, a box plot's been drawn and it's not fully correct. Write down 2 things that Aisha should do to make it correct. Okay. Well, just look carefully for something. The median is 162, but she seems to have drawn it here at 161. So the first thing to write down is that the median should be at 162. Okay, that's the first thing. And the second thing is, now this is perhaps a little bit more difficult to see. You've got the lower quartile at 154. Okay, the interquartile range is 17. So that means that the distance between the lower quartile and the upper quartile is 17. So if you add 17 onto that, okay, you get the upper quartile. Okay, so the upper quartile would be equal to 154, 171. Okay, and what's happened here is it's been plotted at 172. So UQ upper quartile should be at 171, and that will do. I've identified 2 things. You could mark those on the graph if you wanted to as well, I suppose, just to make it clear what you were doing. I'll just put a little dash there and there to show the 2 things that I identified as being wrong, but I think you need to write them down in there as well. Okay, right, this is straightforward stuff. For if it's 1 mark, it's either right or wrong. Anything to the power 0 is 1. Okay, anything to the power of 0 is 1, except for 0 to the power of 0, which is undefined, but you wouldn't be asked that anyway. This one here is a fraction, an algebraic fraction, but it's already been factorized, and if you see it written like this, okay, don't multiply out the brackets. That would actually complicate things more. Okay, because when you simplify algebraic fractions, you keep them factorized as much as you can. Okay, and that gives you x minus 4 times itself, like that. And if you do it like that, you can see straight away that you have a common factor of x minus 4, on the numerator and denominator. So all you need to do is just cancel out an x minus 4 with an x minus 4, and that leaves you with 8 over x minus 4. Okay, 8 over x minus 4. And the last one is worth 2 marks. Now, you've got to cube everything in here. So basically, the 3 is cubed to give you the 27. The n to the 4 is cubed to give you n to the 12. And the w2 is cubed, w squared, to give you w to the power 6. Okay, 2 marks if you get all bits right, 1 mark if any of those 3 parts are wrong. Okay, next. This is a quadratic equation, and it's already set up in the form ax squared plus bx plus c. You might be tempted to go straight for the calculator. Well, you can do, and if you do, you've just got to be really careful. I'm going to factorize it because it does, okay? And to get the 6x squared, you're either going to come from 3x and 2x or 6x and x. In fact, it's quite quick to discover that if you have 2x and x and 3x, it works, okay, with the plus 3 and a minus 5. Plus 3 and minus 5. And that works because if you multiply that pair of brackets out, you will get the original quadratic. And from this, the factors, these are the 2 factors, so the roots or the solutions are, to make this first bracket 0, x would have to be equal to negative 3 over 2, okay, negative 3 over 2, or x would have to be equal to 5/3 for this one to be 0, okay, 5 over 3. So they're the 2 solutions. I'm just going to write them here. X equals negative 3 over 2, or x equals 5/3. Okay, now you don't actually need to write them in 2 places. I could have just gone straight over here and written them, but they're done now. Now, if we wanted to use the quadratic formula, I'll just do this in a different colour. There's nothing wrong with that, but you've just got to be careful and identify first what A, B and C are. Okay, A is 6. Okay, B is negative 1. That's the number in front of the x, you see, and C is negative 15. Okay, so you were using the quadratic formula. You would be saying that x equals minus b, okay, which is minus of negative 1, which is actually plus 1, plus or minus the square root of b squared, which is negative 1 squared, minus 4 times 6 times negative 15. Okay, and you need to write that out really as it is first. All of that, okay, so that's b squared minus 4ac, you see. And once you've written all that out, you've still got to divide the whole lot by 2a, which is 2 lots of 6, which is 12. Okay, so it would be very easy to go wrong with the minus signs here, and if you put that, work out that square root, you've got, so this is minus minus 1, which is 1. That's plus or minus the square root of 361. Okay, and you may not know that that's 19, but it is. And this is 12 underneath, okay, and if you then process that further, you get, because that's 19, that's 1 plus or minus 19, okay, over 12, Okay, and you can see from that you'd get your solutions that we've got over here. Okay, because 1 plus 19 is 20. 20 over 12 is 5/3, and 1 minus 19 is negative 18, so it'd be negative 18 over 12, which is negative 3 over 2. So it's quite nice to see that it works. Okay, in this case, if you spot the factorization, it's quicker. If you do use the quadratic formula, just be really careful with the minus signs, and on the calculator, any minus number, put it in its own bracket like that. Okay, right, next question. Number 10, a transformation. We've got to describe the single transformation that maps shape A onto B. Let's just take a corresponding point and join them together. This is an enlargement, okay? And I'm taking the right angle of each triangle and joining them together. Now I'll take this point and join it to its corresponding point over here. There it is. Okay, now we need to write down, to get the marks, some information. What sort of transformation is it? We must do that. That's an enlargement. Okay, that word has to be there. An enlargement has a scale factor. The scale factor of this one is negative 1.5. Okay, it's negative because it's going upside down through the center of enlargement and out the other side. It was 2 across, it's now 3 across. It was 2 high, it's now 3 high. It's 1.5 times bigger, or 3 over 2 times bigger. And the center of enlargement, okay, is the point through which those ray lines cross or meet. And that is the point with coordinates 1, 1. Okay, so you need the description word, you need the scale factor, and you need the center of enlargement. A quadratic sequence, okay, classic situation here. Use the most common method, which is a little table that we're going to do. Okay, so I'm going to start by just very quickly sketching a table and showing you how this normally works. Just have a few horizontal lines like that. Okay, and I think one more. And what we're going to do is we're just going to start by writing on the top here n, which is the position in the sequence. 1, 2, 3, 4, 5. Okay, and then underneath that the actual terms of the sequence, which I tend to call capital S. So that's 10, okay, 21, 38, 61 and 90. Then I do this. I work out the first difference, okay, 11, 17 and 23 and 29. I expect those to go up as an arithmetic sequence, which they do. If they didn't, it wouldn't be a quadratic sequence. And the second difference I need, which should be a constant, and in this case, of course, it's 6. I then take half of 6, which is 3, and multiply it by n squared. So that 3 is half of the second difference. Right, 3n squared. Well, if n is 1, 3 times 1 squared is 3. 3 times 2 squared is 12. 3 times 3 squared is 27. 3 times 4 squared is 3 16ths, which is 48. 3 times 5 squared is 75. Now I subtract from S, I subtract 3n squared. In other words, the last two rows I've just written, I subtract from each one. 10 take away 3 is 7. 21 take away 12 is 9. 38 take away 27 is 11, and so on. This should be either a constant number all the way through or an arithmetic sequence. This is an arithmetic sequence or a linear sequence because it's going up by 2's. Okay, so this is the sequence 2n, okay, plus 5. And the reason it's plus 5 is because the term before the 7 would be a 5. The 0th term is 5. So the formula for our whole sequence is made up of this part, what I call the quadratic part, plus the linear part. Okay, and so it's 3n squared plus 2n plus 5. There is another algebraic method, and I've done a video on that, which you might want to look at. But this method is the textbook method that you've probably seen and been taught, and is very commonly used. Okay, next. Simplify n cubed times n to the 5. You add the indices together and you get n to the 8. It's either right or wrong. This one's worth 2 marks because you've got to work on the numerator and denominator. If you divide, you subtract the indices. So c cubed divided by c squared is just c. Okay, and d to the 4 divided by d to the 1, if you like, is d cubed. cd cubed. Okay. This is a simple inequality to solve. Treat it like an equation, but use the inequality sign. Doubling both sides, I get that. Okay, 5x is greater than 14. Well, if 5x is greater than 14, x is greater than 14 over 5. Okay, and that's it. I can write that as 2.8, but I don't need to. I can just leave it as x greater than 14/5. Leave your working in, okay, and that's 2 marks for that part of the question. So make sure you've got a bit of working out to support it. Next, okay, now for this question, this is about speed and distance and time. So Andy is on a some sort of event where he's got to cycle and then run. So speed, distance and time, the connection, you must have seen this before. If I just do this triangle here like this, you can see that you've got in the top here speed, down here is distance divided by time. Okay, that's the one that people tend to remember, and you can use it in a different order. So to get the time, which is what we're looking for here, the total time, right, it's distance divided by speed. Okay, so if we take the first part, we've got his distance and we've got his speed. So 30 divided by 24, okay, plus, now we've got the running part is 12 divided by 8. Okay. Now, if we want to add those together, we need to find a common denominator. Well, actually, the easiest thing here is just to divide that one top and bottom by 3 to give us 10 over 8. Okay, plus 12 over 8. Okay, and that gives us 22 over 8. And 22 over 8 is the same as 11 over 4. And 11 over 4 is 2 3/4. So the whole thing took 2 3/4 hours. Well, that's 2 hours and 45 minutes. Okay. Next question. Right. Macy knows that she needs 3 kilograms of grass seeds to make a rectangular lawn that size. Okay, so 5 by 9 is 45 square meters. Okay, so we need to show all of our working here. Okay, so what I need to do is put some calculations in. So 5 times 9 is 45. Okay, so that's showing that I know the area of the lawn that she knows about, which is 3 kilograms. And I just put 3 kilograms there like that. Okay, so therefore 45 divided by 3. Okay, so what I'm doing here is I'm showing how much she can cover with 1 kilogram. So I'm putting 15 meters squared, 1 kilogram. Okay, so I know that for every kilogram of seed I've got 15 meters squared, and 1 box is 30 meters squared. Okay, 1 box, because 1 box equals 2 kilograms. Okay, and I can put in there 30 meters squared. So there's all these sorts of things I can draw from the information given. Okay, now she's got to cover a lawn 10 by 14, which is 140. So 10 by 14 equals 140. Okay, now I'm going to find out how many kilograms she needs. So 140 divided by 15. Okay, and that gives me on the calculator 9 1/3. Okay, 9.3 recurring. Okay, kilograms. Now that's how many kilograms of seed she needs. She has 5 boxes, which is 10 kilograms. So 1 box equals 2 kilograms. 5 boxes. 5 boxes equals 10 kilograms. Okay, so what I can say is that she does have enough seed. Okay, so Macy has, what's the question? Has Macy got enough grass seed? Yes. So Macy has enough, since, okay, and it's this comparison thing again, isn't it? Since 9.3 recurring is less than 10. Okay, so you've got your numerical comparison that justifies your answer. Okay, now in part B, does this affect whether Macy has enough grass seed to make her own lawn? And that's because she's now found that one of the boxes only contained 1 kilogram of seed. So what I'm going to do here is I'm going to say I've got 4 boxes of 2. 4 times 2 plus 1 equals 9 kilograms. Okay, so she's a kilogram short. Okay, so the answer is, does this affect whether she has enough grass? Yes, it does affect it. Okay, since 9.3 or 9, yeah, okay, it doesn't matter which way around you do it as long as it's clear. Since 9.3 is greater than 9, okay, in other words, she needs more seed than she's now got, so not enough seed. Okay, so not enough. Okay, So just make sure that your conclusion is supported by some kind of numerical statement and comparison. Number 15. This question is really straightforward. It's only 1 mark, so there can't be much to do. They've drawn the straight lines for you. Okay, they haven't asked you to draw them. They just want the solution to the simultaneous equations given. Well, it's simply this. Look at where the 2 straight lines cross. What's the x-coordinate? The x-coordinate is -2. What's the y-coordinate? 4. That's the answer that they're looking for. Okay, just 1 mark. X equals -2, y equals 4. Last question. Okay, a total of 45 boys and girls in a choir, 18 boys, the average age or mean age is 16.2, and the girls, there's 27 of them with a mean age of 16.7. We've got to calculate the mean of the total. This is what we do. Okay, we do 18 times 16.2. In other words, what we're doing is finding the total ages. Finding the total of adding the ages of all the boys together. Okay, plus the same with the girls. Okay, and then that's giving us a total of 45 girls and boys with all of their ages added together. And we divide that by the total number of them, which is 45. Put that on a calculator, and you do get 16.5. That's the answer. And that's it. That's the answer. Now, you don't need to put these brackets in here, but you can do if you want, just to make it clearer to yourself. What you must not do is add together 16.2 and 16.7 and halve it, because that will give you a different answer. It gives you 16.45, and if you then rounded it, you would get 16.5, but it's wrong. And if the answer appeared on its own without any working, you would get 0 marks. So you've got to have evidence of how you got your answer, okay? And the only way it would work to add them both together and divide by 2 is if the number of boys and girls was the same in this, and they're not. Okay, so that's it. That's the end of the paper, and I hope that was helpful.